Case 1 practice here with number 2. Just make sure on your test that you are doing completing the square when it asks you for completing the square and not the method that they're asking for at number 5. But I think I'm probably just going to practice this one, number 2. We've been doing method 5. Here, let me show you what I mean. On this one right here, question 5, you start with the x equals opposite of b over 2a and go through that process. So I think you can look at the answer key and see where I'm getting that from. But let me practice some of these things with this method here. So number 2, the first thing I want you to do is I want you to think about separating your front part of the problem here, negative x squared plus 10x plus blank, separating that from the 21. So I'm going to put minus 21 here, and if we're adding something, we're going to have to subtract the exact same thing. All right, but here's the concept is that we have a trinomial, or we can create a trinomial here now the way we want it to. Well, we cannot do this if this negative 1 is out front here. We won't be able to have that. So we got to factor out the negative 1. So negative 1 comes out, negative 1. And then we're going to have on the inside positive x squared now because we took the negative out, minus 10x. It's still going to be a plus because it has to be a plus for a perfect square trinomial in there. Then I still have the minus 21 and the minus blank. So how do we fill out our blanks? Well, we've talked a lot in class about why this is true, so I hope you know that a perfect square trinomial will always follow the process of taking half of this value, which is 5, and squaring it, which is 25, and putting that in the blanks. Now, here's the problem with me doing what I just did in blue. This does say plus 25, that does say minus 25, but unfortunately, this plus 25 is not really a plus 25. You need to think about this negative 1 out front here. When I distribute this through, that actually says negative 25. I've actually subtracted 25. So to counteract that, I got to put a positive 25 on the back end. The other thing is, think about how this vertex is supposed to come out. If it comes out to be way off the chart, you're probably doing something wrong. All right, so vertex form for this one is going to be f of x is equal to the negative 1 out front, and then we have x minus 5, quantity squared, plus 4. So I'm not going to rewrite that, but that would go right into that answer blank, vertex form. The vertex, so we're going to go right 5, we're going to go up 4. So that would be 5, 4, and the axis of symmetry is x equals 5, because that's the x value of the vertex. So this is very hard for me to graph on this program. I'll try my best. 1, 2, 3, 4, 5. It's like right here. There's my axis of symmetry. And then up 4, 1, 2, 3, looks like it would be right about there. And then I'm going to go down, over 1, down 1, over 1, down 1, over 2, and down 4, which is going to lead me right back to the x-axis. You can put more points on there, be accurate doing that, but this is hard to do on here, so I'll leave it at that. X-intercepts. You can find them algebraically, or you can just look at your graph. But they're the x values when y is 0. So if I just look at my graph, this worked out really nice to have 2 x-intercepts, which are at 3, 0, and it looks like 7, 0. The y-intercept is the y value when x is 0. So if I go even way back up here, think about putting x of 0 in there, you're going to get negative 21. So that's something I'm definitely not going to see on the graph, 0, negative 21, but it makes sense that this would go way down here and cross at negative 21. Domain on all of our quadratics has been all real numbers. Makes sense if you think about that, left to right. The range, we will go all the way down to a negative infinity. Y value is all the way down here, all the way up to a maximum point of, or value of 4, and we do have that value, so that's a bracket there. And then just to refresh the increasing, the values are going up. Like the values are going up, going up, going up, going up, until this point, but don't answer with how high they get, answer with where they get. So that's why we use the x value when we do these intervals. So it's negative infinity all the way to the x value of 5. That's where it's increasing. And then from that point forward, it's decreasing. The y values are going down. Okay, hope that helped.